So right. So the next one is space technology. Space technology. So in this space technology, you have to remember, you have to understand some basic terminologies like what is space. So what is a rocket, then payload, then satellite, orbit, then perigee, apogee. So all these terminologies you have to understand. So first of all, what is meant by space? What is space? So it is the three-dimensional space which starts when the Earth atmosphere ends. It is a three-dimensional space, three-dimensional region where the Earth atmosphere ends. Suppose say if you observe the Earth atmosphere, it contains different layers like troposphere, stratosphere, mesosphere, and thermosphere. In this thermosphere we have ionosphere and exosphere. So this exosphere, it is called as outer space. So it is a three-dimensional region, starts when the Earth's atmosphere ends. The extremely low temperature, extreme conditions are there, that is called as space. Just to remember. And what is meant by rocket? Rocket, it is also called as launch vehicle. Rocket means it is a launch vehicle which carries the payloads. And the rocket works on the principle of Newton's third law of motion. Newton's third law, you remember this one. That's enough. The launching of rocket is based on the Newton's third law of motion. Newton's third law says that every action has an equal and opposite reaction. Every action has an equal and opposite reaction. So this is rocket. When you burn the fuel, it provides a thrust. The thrust will push us the rocket upwards. This is the rocket. And what about payload? So payload means any object which is sent into the space. Any object which is sent into the space. Any object sent into the space, that is called as a payload. For example, the satellite may be a payload. Satellite may be a payload. Astronaut may be a payload. Astronaut means the space traveler. Astronaut means the space traveler. It is called as a payload. And then what about satellite? Satellite means any object which is revolving around an object. Anything which is revolving around an object, that is called as a satellite. Anything which is revolving around, another object, that is called as a satellite. Okay. And next, what about orbit? What is orbit? So say this is a Earth. The path followed by a satellite around the Earth, the path or the direction followed by a satellite is called as orbit. The path or direction followed by a satellite around the Earth is called as an orbit. So this orbit may be either circular or it may be elliptical. So it is a circular orbit, and say this is a elliptical orbit, oval shaped orbit. See, orbit, it may be a circular orbit. This is circular orbit. Orbit may be a circular or it may be an elliptical orbit. Orbit means the path followed by a satellite around the earth, that is called as a orbit. It may be circular or it may be elliptical. Here the radius of this orbit is same in all directions. Here the radius is same in all directions. Whereas in elliptical orbit, suppose say this is satellite, sometimes it may be located here, it may be located here. So this is the nearest distance, this is the farthest distance. Okay, and here you come across two terminologies like perigee and apogee. You remember these two terminologies, perigee and apogee. So what is perigee? The point in a satellite elliptical path, around the earth, at which it is closest to the earth's center. So what is perigee? The closest point from the center of the earth. The point at a satellite elliptical path, around the earth, at which it is closest to the earth center. That is called perigee. And next, apogee. It is the point on the satellite elliptical path at which it is farthest from the earth center. That is called apogee. Closest perigee, farthest apogee. Okay, all right. And then next. Over. Right. Next, let us see orbits. Types of orbits. So I already told you, orbit is a path or a direction around the earth. The orbits may be geostationary orbit, or it is also called as geosynchronous orbit. Next, LEO, low earth orbit. Then MEO, medium earth orbit. And SSO, sun synchronous orbit, or it is also called as PSO. Means polar synchronous orbit. Low earth orbit, medium earth orbit, solar synchronous orbit, or polar orbit. Right. These are different types of orbits. Let us see geostationary orbit, or it is also called as geosynchronous orbit. So some important points about this geostationary or geosynchronous orbit. So here the orbit is circular. Like this. Satellite is placed at 36,000 kilometers and above. Satellite is placed at a distance of 36,000 kilometers from the surface of the earth. Okay. And here you remember the terminology footprint. Footprint of the satellite. Footprint of the satellite is 1/3. 1/3. This point you have to remember first. So what is geostationary orbit? The orbit is circular. The shape of the orbit is circular. And the satellite is placed at a distance of, suppose say this is earth and this is a satellite. Okay, this is the orbit and this is a satellite. This is the satellite. This is earth. Okay, it is placed at a distance of 36,000 kilometers. 36,000 kilometers. And its footprint is 1/3. What is meant by footprint? Footprint is 1/3. 1/3 means what? So as the satellite is placed at a far distance, it can cover nearly 1/3 part. It can cover 1/3 part of the earth. That means theoretically 3 satellites are enough to cover the entire globe. Are you getting? So that means this satellite covers this part and this satellite covers this part and another satellite will cover this part. Are you getting? That means 1/3 means the satellite covers 1/3 of the geographical area on the globe. That is called as its footprint. As it is far away, it can cover the maximum distance. It can cover the maximum geographical area on the surface. That is called as its footprint. And then why it is called geostationary? Why it is called geostationary? Why it is called geostationary? That means looking from the earth surface, looking from a fixed point on the earth surface, the satellite appears to be stationary. When you observe the satellites in this direction, the satellite appears there. When you observe in this direction, the satellite appears there. When you observe in this direction, the satellite appears there. Okay, looking from a fixed point from the earth surface, the satellite appears to be stationary. Why it appears to be stationary? Because the satellite moves with, the satellite rotates with rotational speed of earth. The satellite rotates with rotational speed of earth. Whatever may be the speed, it rotates with the rotational speed of the earth. Rotates with rotational direction of earth. Rotates with rotational direction of earth. So rotational direction, that is eastward. Eastward direction. Eastward direction means west to east. West to east. The satellite rotates with the rotational speed of the earth and it rotates with the rotational direction of the earth, that is eastward direction, that is west to east, like this. So west to east direction. And there is no inclination. Inclination with respect to earth, is 0. Inclination with respect to earth is 0. That means it is not making any angle with the plane of the earth. So inclination with respect to earth, that is it is making 0 angle. No angle, 0 degree angle. So that's why the satellite is geostationary. So that means the satellite rotates with the rotational speed of the earth, rotational direction, that is eastward direction, and there is no angle. So the plane of the, that means it is not making any angle with the plane of the earth, 0 angle. So that's why that is called as inclination. Inclination with respect to earth is 0. So that's why the satellite appears to be stationary. Are you getting? Right. This is geostationary. And then what about geosynchronous? What about geosynchronous? Geosynchronous. So all these conditions are same. That means the satellite is placed at a distance of 36,000 kilometers. The footprint is also same. The satellite rotates with the rotational speed of the earth. Okay. But rotational direction also. But its inclination is not 0. It is making some angle. Suppose say for example, this is earth and this is the plane of the earth, equator. So this is plane. So this is geostationary. Geostationary means the satellite, that means satellite is rotating like this. Got it? This is axis. Okay, the earth is rotating like this. Okay, earth is rotating like this. Here satellite is also rotating like this. Okay, this is geostationary. Got it now? But geosynchronous, in all respects it is same, but it is making a slight angle like this, tilted like this. Got it? It is rotating like this, geostationary, but geosynchronous, it makes an angle like this, tilted like this, This direction. Got it? So that is called as the geosynchronous. That is the difference here. So that is, here it is making a slight angle. It is making a slight angle. And here like this. It is making a slight angle like this. Right? This is called as geosynchronous. Got it? Right. Next, low Earth orbit. Low Earth orbit. Low Earth orbit. Here also the orbit is circular. The orbit is circular, but the satellite is placed at a distance of 500 to 1500 kilometers. Satellite is placed at a distance of 500 to 1500 kilometers above the Earth's surface. Above the Earth's surface. So low Earth orbit. Orbit is circular. The satellite is placed at a distance of 500 to 1500 kilometers. And these orbits are mainly used for mobile communication. Mobile communication, and they are used for remote sensing purpose. Mainly these orbits are used for mobile communication and they are for remote sensing purpose. Remote sensing purpose. So the International Space Station, ISS, International Space Station, Hubble Telescope, the International Space Station, Hubble Telescope, and various space shuttles, are kept at LEO. They are kept at LEO. Next, MEO, medium Earth orbit. Medium Earth orbit. So actually, say this is Earth. Say this is LEO, and this is a GSO. Say this is LEO, and this is GSO. In between these two, at a distance of 10,000 to 20,000 kilometers. At a distance of 20,000 kilometers. In between 10,000 to 20,000 kilometers, the satellites are kept. That is called as the medium Earth orbit. So what is medium Earth orbit? In between low Earth orbit and in between GSO, geostationary orbit, the satellites are kept at a distance of or at an altitude of 10,000 to 20,000 kilometers from the Earth's surface. That is called as medium Earth orbit. Medium Earth orbit. Medium Earth orbit. Right. Next. Over. and most of the communication satellites are launched in the medium earth orbit. Here in geostationary orbit, the satellites for communication purpose are launched here. In geostationary orbit, the satellites for communication purpose or communication satellites. Communication satellites are launched. Communication satellites. Okay, in medium earth orbit also the communication satellite. And next one is sun synchronous orbit. SSO. Sun synchronous orbit. The satellite rise and set with the sun. Sun synchronous orbit. Satellite rise and set with the sun. So suppose say this is earth, this is a equator. Okay, this is axis. As the satellite, suppose say satellites, it is an elliptical orbit. The sun synchronous orbit is an elliptical orbit. The orbit is elliptical. Here the satellite rises as set with the sun. That means the satellite is facing towards the sun, not towards the earth. Okay, as it is facing towards the sun, okay, it is making an angle of 90 degrees. So inclination is 90 degrees with respect to the earth. Inclination with respect to the earth is 90 degrees. The sun synchronous orbit, or it is also called as polar synchronous orbit. That means what it is, suppose say this is an axis. This is axis of the earth. The earth is rotating in this direction. Got it? The earth is rotating in this direction. But the satellite rotates in this direction. Okay. It is in elliptical orbit and it is in circular orbit. Okay. But here it makes an angle of 90 degrees with the earth's axis. Earth's plane. Is it clear? That is called as a sun synchronous orbit, or it is called as polar synchronous. So polar synchronous, or simply it is called polar orbit. So why it is called polar orbit? Because it is covering the poles of the earth. Because it is covering the poles of the earth. That's why it is called polar orbit. Polar synchronous or polar orbit. Most of the remote sensing satellites, the satellites launched for mapping, satellites for mapping and surveillance, satellites launched for mapping and surveillance are launched in this polar orbit. Satellites for, or you can say spacecrafts for mapping and surveillance purpose are launched in the polar orbit, or you can say sun synchronous orbit. Sun synchronous orbit. Right? And next, let us see what? Next, let us see types of satellites. Types of satellites. These satellites have been broadly classified into two types. The satellites have been broadly classified into two types. They are communication satellites, and other than communication satellites. So communication satellites and other than communication satellites. Here communication satellite. So communication satellites, to provide a communication, to provide a worldwide link up of, telecommunication. telecommunication, TV and radio broadcasting, and providing internet services, So all modes of communications. For example, INSAT satellites. So satellites are broadly divided into two types: communication satellites and other than communication satellites. To provide a worldwide link-up of telecommunication, television broadcasting, radio broadcasting, and providing for internet services. Example, INSAT satellites. INSAT satellites means Indian national satellites. These are mainly meant for communication purpose. And other than communication. So the main purpose is other than communication. So these may be the communication satellite, but the main purpose is other than communication. Say for example, there are various types of satellites. These includes Earth observation satellites. Astronomical satellites. Navigation satellites. Reconnaissance satellites and weather satellites. Earth observation satellites. So Earth observation satellites, the name itself indicating, they are mainly meant for resource monitoring, Earth observation purpose. Earth observation or resource monitoring purpose. Example, IRS satellites. IRS means Indian remote sensing satellites. Then astronomical satellites. To observe the distant objects like galaxies, stars, and other celestial bodies. Astronomical satellites. For example, various types of telescopes. Hubble telescope. So astronomical satellites means to observe the distant planets, galaxies, and also other celestial bodies. So these are called as the astronomical satellites. So various telescopes launched in the low Earth orbit. Okay, and then navigational satellites. It aids in navigation, direction. That is to locate exact position, and also to direct the objects. Some satellites have been launched. These are called navigation satellites. For example, the satellites in the GPS system, global positioning system, the satellites in the IRNSS, Indian Regional Navigation Satellite System. Navigation satellites, the satellites in the GPS system, global positioning system, satellites in the IRNSS, Indian Regional Navigation Satellite System. Next, reconnaissance satellites. Reconnaissance satellites means meant for both observation, they are mainly meant for both observation and communication. The satellites which are meant for both observation purpose as well as for communication purpose. These are called as reconnaissance satellites. Say for example, some satellites have been launched for surveillance purpose. For example, military satellites. You consider some military satellites. And then weather satellites for monitoring weather conditions. So these are called weather satellites. Right. So this is the overview of the satellites. Satellites have been broadly classified into communication satellites and other than communication satellites. So communication satellites mean they are mainly meant for communication purpose only. For example, in that, other than communication, they may be earth observation, astronomical, navigation, reconnaissance, and weather satellite. This is the overview of the satellite. Right. Next, let us see Indian space system. So Indian space system. Indian space system. So after independence, we didn't have any separate department for this space-based activities. So for the first time in 1961, the responsibility of space-based activities was given to DAE, Department of Atomic Energy. In 1962, Department of Atomic Energy, DAE, was established an INCOSPAR. INCOSPAR means Indian National. INCOSPAR means Indian National Committee for Space Research. Indian National Committee for Space Research under the leadership of Dr. Vikram Sarabhai. Okay, later the INCOSPAR was reconstituted as an advisory body. So after that, in 1969, on August 15th, you remember this date also, the ISRO was established. ISRO means Indian Space Research Organization. So in 1969, August 15, ISRO was established, Indian Space Research Organization, and it was headquartered in Bangalore. You remember this one? Later in 1972, Space Commission. You remember this year? Space Commission and DOS. DOS means Department of Space. DOS means Department of Space was established. DOS means Department of Space was established. And this ISRO brought under this Department of Space, ISRO brought under DOS, Department of Space, on 1972 June 1st. You remember this basic factual information related to ISRO. So in 1962, DAE established INCOSPAR. INCOSPAR means Indian National Committee for Space Research under the leadership of Dr. Vikram Sarabhai. In 1969, on August 15th, ISRO was established, Indian Space Research Organization. It is headquartered in Bangalore. In 1972, Space Commission, Department of Space was established. Then, in the same year, on June 1st, the ISRO brought under Department of Space. Then, what are the activities of this ISRO? ISRO implements the directions and decisions of the Space Commission. ISRO mainly involves in the construction of various launch vehicles, launching of launch vehicles, and launching of various satellites, okay, and providing space-based services to the user community. ISRO is responsible for launching various satellites and launch vehicles and also providing space-based services to the user community and also providing launch pads to the other nations and also leasing these transponders, okay, transponders to other nations. All these are the activities of the ISRO, right? And next, write down some other organizations related to space mission. There is space system, Antrix Corporation Limited. And next one is Antrix Corporation Limited. Antrix Corporation Limited. It is called ACL. Antrix Corporation Limited. It is also headquartered in Bangalore. It is a commercial and marketing arm of ISRO. It is a commercial and marketing arm of ISRO. Okay. Antrix Corporation Limited. Simply you remember it is headquartered in Bangalore. It is a commercial and marketing arm of ISRO. Next, NSIL. NSIL. And the next one is NSIL. New Space India Limited. It was established in March 2019. NSIL, New Space India Limited. It was established in March 2019 as CPSC. Central Public Sector Enterprise. Central Public Sector Enterprise. It comes under the administrative control of DOS, Department of Space. It was established in March 2019 as CPSC, Central Public Sector Enterprise. It comes under the administrative control of DOS, Department of Space. And the main objective of NSIL is to scale up industry participation in Indian space program. To scale up industry participation in Indian space program. Indian space programs. So that means Antrix Corporation Limited, ACL, is also a commercial and marketing arm. NSIL is also like that, but mainly it focuses on the Indian industry, that is national industry. Okay. So for participation in the space-based activities. Okay. Right. Next, in space. Another one is in space. You write down like this: INSPACE. In space. Indian National Space Promotion and Authorization Center. Space Promotion and Authorization Center. Headquarter is Ahmedabad. Right on. It is a single window independent. It is a single window independent nodal agency. It is a single window independent nodal agency. Nodal agency that functions as an autonomous agency in the department of space. It is a single window independent nodal agency, single window independent nodal agency that functions as an autonomous agency in the department of space. In the department of space. So it is acting as a medium between ISRO. It is acting as a medium between ISRO and private space sector in India. It is acting as a medium between ISRO and private space sector in India. Private space sector in India. Right, next to put some heading rockets. Right. So next one is rockets. Rockets, or these are also called as launch vehicles. Launch vehicles. In India, the development of rockets began in the early 1970s. ISRO has developed various types of rockets. ISRO has developed various types of rockets like historic launchers like SLV and ASLV. SLV and ASLV. Then operational launchers or operational rockets like PSLV and GSLV. And also ISRO developed SSLV, that is a small satellite launch vehicle. And also ISRO developing its own cryogenic technology. Cryogenic rockets or cryogenic technology. And also ISRO is developing LOX methane engine. LOX methane engine means liquid oxygen methane engine. So cryogenic technology. And also ISRO is developing reusable launch vehicle. RLV, and also hyperplanes. That is a scramjet technology. Hyperplanes. So these are various types of rockets developed by ISRO. So ISRO already developed historic launchers like SLV and ASLV, operational rockets like PSLV, GSLV, and also in this GSLV, again GSLV Mk3. It's an advanced version of GSLV, that is GSLV Mk3, and SSLV, small satellite launch vehicle. ISRO developed cryogenic technology, and LOX methane engine, reusable launch vehicles, and also hyperplanes. So let us see historic launches. So briefly remember historic launches. The historic launches, historic rockets like SLV. SLV means satellite launch vehicle. Satellite launch vehicle. Satellite launch vehicle. It was developed in the year 1980s. Okay, it is a three-stage rocket which uses solid propellants. Solid propellants like a HTPB. Solid propellant like HTPB. HTPB means hydroxy terminated polybutadiene. It utilizes, so that means SLV, it is called satellite launch vehicle. It was developed in 1980s. It is a three-stage rocket. All three stages utilizes, that is the solid propellant like this. First, second, and third stage. All three stages utilizes solid propellant. Okay. So Rohini satellites were launched with the help of this SLV3. Rohini satellites. For the first time, Rohini satellites were launched with the help of SLV. And the next one is ASLV. ASLV means augmented satellite launch vehicle. Augmented satellite launch vehicle. So augmented satellite launch vehicle means it is an advanced version of SLV. It was launched for the first time in the year 1992. It is a five-stage rocket with all solid propellants. All five stages launch with solid propellants. 5-stage rocket with all solid propellants. That is ASLV. Right. So the next one is PSLV. PSLV means Polar Satellite Launch Vehicle. Polar Satellite Launch Vehicle. PSLV. It was first launched in the year 1997. So to launch IRS satellites, IRS means Indian remote sensing satellites. To launch Indian remote sensing satellites to low Earth orbit, LEO. To SSO. remote sensing satellites to SSO, Sun Synchronous Orbit. PSLV, it is a polar satellite launch vehicle. For the first time it was launched in the year 1997. So it was developed to launch IRS satellites. IRS means Indian Remote Sensing Satellites to Sun Synchronous Orbit. It is also called as workhorse of ISRO. With the help of this PSLV, we launched various types of rockets. If you observe the payload carrying capacity of this PSLV, if you observe payload capacity, it can carry 3,250 kgs of payload to LEO, low Earth orbit, 1,600 kgs of payload to SSO, Sun Synchronous Orbit, and 1,400 kg of payload to GTO, Geostationary Transfer Orbit. You remember that one? It carries 3,250 kgs of payload to low Earth orbit, 1,600 kg of payload to Sun Synchronous Orbit, and 1,400 kgs of payload to GTO. GTO means Geostationary Transfer Orbit. Before entering into the GSO, it enters into GTO, Geostationary Transfer Orbit. Next, if you observe the variants of this PSLV, there are 4 variants of it. PSLV CA variant, PSLV CA variant, XL variant, PSLV DL variant, and PSLV QL variant. So these are the 4 variants of PSLV. CA means core alone, no strap-on boosters. PSLV XL variant, it contains 6 strap-on motors, or you can say strap-on boosters. And DL variant, it contains 2 strap-on motors. QL variant, it contains 4 strap-on motors. First, you remember, I'll let you know this one. So in PSLV, there are 4 variants are there. In PSLV, there are 4 variants. That is CA variant, XL variant, DL variant, and QL variant. PSLV, CA variant, XL variant, DL variant, and QL variant. PSLV CA means core alone. XL variant, you remember the strap-on motors. So strap-on motors. What are strap-on motors? Boosters. Strap-on motor. So listen. So actually, this is a rocket. And say this is a rocket. Okay. Right. This is normal rocket. It is having different stages like this. First stage, second stage, third stage, and fourth stage. It is a 4-stage rocket. This is a core alone rocket. Got it? It is core alone rocket. But here in XL variant, DL variant, and QL variant, extra thrusters are present like this. They are parallelly arranged like this. So these are called strap-on motors. Strap-on motors, or you can say strap-on boosters. So these are, what are these strap-on motors or strap-on boosters? These are supplementary thrusters. Supplementary thrusters, which provides extra thrust to the rocket. So that is a core alone, no strap-on motors. XL variant, it is having 6 strap-on motors. Just to remember that one. DL variant, 2 strap-on motors. QL variant having 4 strap-on motors. 4 strap-on motors. So that is a PSLV, strap-on motors. Then PSLV having 4 stages. PSLV is having 4 stages, which utilizes both solid and liquid propellants. Solid propellant and liquid propellant alternatively. The first stage, it utilizes the solid propellant called HTPB. HTPB I already told you, hydroxy terminated polybutadiene. You remember this one. In the second stage, it uses the liquid propellant called UDMH. Liquid propellant called UDMH. So what is UDMH? Unsymmetrical dimethyl hydrazine. Unsymmetrical dimethyl hydrazine. So first stage, say this is first, this is solid propellant. Second stage, liquid propellant. Third stage, again solid propellant. And the fourth stage, it contains again liquid propellant. A third stage, it contains again solid propellant HTPB. The fourth stage, it is having the liquid propellant UDMH. So you remember the first and fourth stages. First and third stages, they contain solid propellant. The second and fourth stage contains liquid propellants. Okay, so that means you have to remember this is important. PSLV is having 4 stages. That means first stage, second stage, third stage, fourth stage. It carries 4 stage propellants. Okay, propellant means fuel plus oxidizer. Propellant means what? Fuel plus oxidizer. Fuel plus oxidizer. Together called as propellant. Okay. Fuel plus oxidizer. The first stage, solid propellant. Second stage, liquid propellant. Third stage, solid propellant. Fourth stage, again liquid propellant. Alternatively, just to remember first and third, solid. Second and fourth, liquid propellant. And here, the nitrogen tetroxide oxidizer. Oxidizer is N2O4. N2O4 means nitrogen tetroxide. N2O4, nitrogen tetroxide. It is an oxidizer. Right? So this is PSLV. If you observe some of the achievements of this PSLV, if you observe the achievements of PSLV, it carried Chandrayaan 1, the spacecraft like Chandrayaan 1, and also MOM, Mars Orbiter Mission, or it is also called as Mangalyaan. So the Chandrayaan 1 was carried with the help of PSLV C11. You remember this one. In the year 2008. Whereas Mangalyaan or Mars Orbiter Mission, it was carried by PSLV C25 in the year 2013. And also another achievement is PSLV C37. You remember this one. The PSLV C37 carried nearly 104 satellites. 104 satellites in a single flight. 104 satellites in a single flight. That is a Cartosat 2 and other 103. So these are the major achievements of PSLV. PSLV C-37 carried 104 satellites in a single flight, which includes Cartosat 2 and 103 other co-passengers. 103 other co-passengers. Recently, the PSLV C-57, the PSLV C-57 XL variant carried Aditya L1 mission. Aditya L1 mission. And PSLV C-58 carried ExpoSat and VSat, Women Engineered Satellite. This was given in recent exam. Okay. So PSLV C-57, PSLV C-58. The PSLV C-57 in the year 2023 and PSLV C-58 in the year 2024 January 1st. So PSLV C-57 carried Aditya L1 mission, PSLV C-58 carried ExpoSat mission, and also the PSLV rockets were used to launch navigational satellites in IRNSS, Indian Regional Navigation Satellite System. Next to put subheading, GSLV. GSLV. There is Geostationary Satellite Launch Vehicle. So first you compute this one also. PSLV C-58 ExpoSat. Next PSLV C-59, you write down this one also. Okay. PSLV C-59 Proba 3 PSLV C-59 Proba 3 spacecraft on December 5, 2024. Proba 3. So this Proba 3 is an IOD, that means in orbit demonstration of European Space Agency. So Proba 3 mission is a in orbit demonstration of ESA. ESA means European Space Agency. In orbit demonstration of European Space Agency. So it was carried on December 5, 2024 with the help of this PSLV C-59. PSLV C-59. Next, PSLV C-60. PSLV launched SpaceX mission. So PSLV C-60. PSLV C-60 launched SpaceX mission on December 30, 2024. December 30, 2024. So SpaceX mission is the fourth poem, POEM. So SpaceX mission is the fourth poem mission. That means, so PSLV orbital experimental module, PS4 orbital experimental module, PS4 orbital experimental module, orbital experimental module. Okay. So then you put subheading GSLV, Geostationary Satellite Launch Vehicle, Geostationary Satellite Launch Vehicle, GSLV. Okay, so I'll stop here. We'll continue in the next class.